Hi guys, welcome to section 7.1. We're going to be learning how to solve systems of linear equations in two variables. We kind of touched on it in the last lecture, but we're going to go into it in more detail here. So the objectives, we're going to verify solutions to a system of linear equations in two variables. So first we're going to learn how to verify that something is true. Then we're going to learn how to solve using substitution. Also, we're going to learn to solve using elimination. And then we're going to apply that to some word problems to see how that works. Okay. So first thing is, what is a linear equation? Well, we already learned that it's a value to the first power. Remember, the exponent always has to be to the first power. So let's read what this says. A linear equation in n variables is an equation that can be written in the form a1x1 plus a2x2. What that means is that this could be like 2x1 plus 3x2 plus something plus 5x to the 10th, if there's 10 different x's, equals some value. That's a constant. B is a constant. So we could say, instead of B, we can say that's 6. So that would be a linear equation. Notice all of the variables are to the first power, okay? And all the A's, notice what this says, all the A values and the B are real numbers, meaning they can be any value that could be on the number line could be an answer, where at least one of the A's is not 0. Because if they were all 0, then we would have nothing, right? So they're saying at least one of them has to not be 0. Okay. So systems of linear equations in two variables. So a system of linear equations in two variables is the collection of two linear equations in two variables considered simultaneously. Well, let's say what that means. So let's say we have an x and a y. Then we have two different equations. So if we have an x and a y, if you want to solve for x and y, you have to have at least the same number of variables, same number of equations as variables. So since we have two variables, meaning two different values that change, x and y, we have to have two different equations. If we had three variables, we would need three different equations. We will not be working with more than two for this class. But you could have x, y, z, then you would need three equations. Okay, so first thing we want to do is we want to be able to verify. So it says show that the ordered pair -1, 3 is a solution to the system. Well, remember, if it's an ordered pair, it's always x comma y, right? So ordered pair. So here, for this one, basically I'm saying x equals -1 and y equals 3. So we just plug it in and see if it works. So we have, for the first equation, we have 3 times -1 minus 2 times 3 equals, well, let's see what it equals. Instead of saying it's equal to -9, let's see what it equals. So 3 times -1 is -3. Minus 2 times 3 is -6. Minus 3 minus 6 equals -9. So it works for that one equation. Now let's plug it into the second one. So we have -1 plus 3 equals, well, that equals 2, check. So now all we're doing is saying, yes, this ordered pair is a solution to both equations. So this is true, or this is a solution. However you want to state it, we know that this works, okay? I'm gonna get to what this means in a little bit. Actually, I feel like I'd like to start with, let's just keep going. So verifying solutions to a system of linear equations. There's only 3 possibilities for the graphs. Okay, we're gonna get to it right now. So if you were to graph any linear equation, what a linear equation basically means is that it graphs to a line, okay? So there's only 3 possibilities. Either the lines have different slopes and they intersect at one place, okay? So for example, we have two lines. Let's say one of them looks like that and the other one looks like that. Right here, where that meets, that is called the solution. So that's a solution to this system. These are consistent. Anything that has a solution, at least one solution, is consistent. So this is very important. At least one solution are said to be consistent. We will have things that have no solutions. Those are inconsistent. The consistent system has exactly one solution, so it is said to be consistent. Let me reread this because that's not what I said wasn't true. It's this consistent system, this one that I drew here, has exactly one solution right there where they meet. So it is consistent and it's independent. And we'll see the difference. So when something doesn't have a solution, it will be inconsistent. Dependent and independent, we'll see in a second. Okay, there are only 3 possibilities. So we already got one. So now let's look at the second one. The second one is the 2 equations can be different representations of the same line. So for example, if I were to draw this, let's say I were to draw a graph. So here's the equation of one line, right? And what if I were to say that the other line goes right over the top? They're the exact same equation, but they maybe look a little different. For example, like x plus y equals 3. If I multiply everything by 2, I get 2x plus 2y equals 6. Those are the exact same equation. So they would have a solution, it would be consistent, but they're dependent, right? Because they're the same exact thing. So it's consistent but dependent because they're the exact same line. Okay, they depend on each other. And then the last one, and we have pictures of them coming, but the last one is the 2 lines. If they have the same slope and have no intersecting points, it's said to be inconsistent and has no solution. So something like parallel lines are like train tracks. They basically run next to each other and they never intersect. So we can see here that if you have 2 lines that are parallel, which if they're parallel, they have the same slope, then we can see that this is inconsistent because there is no place that these 2 lines will cross. So there's no solution. Okay. And here's the picture that I wanted to show you. So one solution right here. This one has infinite solutions. Every single point, do it in red, every single point on this line is a solution, and there's actually infinitely many points on the line. And here we have, it's inconsistent, it has no solution because they're parallel, okay? So how do we solve equations? There's a couple of different ways. The first way we're gonna look at is substitution. We've already actually used substitution in 1.2. I didn't call it that, but now we're gonna call it that. So again, we're gonna choose an equation and solve for one variable in terms of the other. And I'll show you how to pick. Sometimes it's easier to pick certain ones than other ones. Then we're going to substitute the expression from step 1 into the other equation. And then once we do that, we're going to have one variable instead of two. So substitute the value found in step 3 into one of the original equations to find the value of the other variable. So for example, here I have a system of equations, and we're going to use substitution. So I'm going to pick this equation because all the coefficients are 1. And it makes it a lot easier. If I use the top, I could use either one, but if I use the top one, then I'm going to end up having fractions, right? If I solve for x, x is going to equal something in terms of something else, but the other thing is going to have to be fractions. So I'm going to use this bottom one, and it doesn't matter if I solve for x or y. So let's subtract y from both sides, and I get x equals 5 minus y, okay? So I've taken that and literally just subtracted y from both sides, and I get x equals 5 minus y. And now I can just plug the y value in for x. So since I know x equals 5 minus y, I'm going to plug that in here for this x. So I have 2. Well, x is now equal 5 minus y. Minus 3y equals -5. And then we just solve this equation. So we have 10 minus 2y minus 3y equals -5. I'm going to combine like terms. So -2 minus 3 is -5y equals -5. Now I'm going to get y by itself. I'm going to isolate my y. So I'm going to subtract 10 from both sides. Those cancel, and I get -5y is equal to -15. Then divide both sides by -5. The -5s cancel here, and I get y equals 3. So what am I looking for? I'm looking for an ordered pair. So I'm looking for an x, comma, y. And now I know y is equal to 3. Okay? So let's go back and find out what x equals. Well, I know that x equals 5 minus y because I've already said that's true, right? So that means that x is going to equal 5 minus 3, which equals 2. So my ordered pair here is 2, 3. Okay, so now we have our x, y. What does that mean? Well, actually, I gave myself an extra empty spot here that I don't actually need. Let's delete this. So now that I solved it, I didn't want to graph it because I can't graph it as well, unless I can't graph it as well to see where it intersects. But basically, if I graph these two lines, what we would find is that they intersect at 2, 3. And if you don't know how to graph and you need some help, I'll be happy to help you. But basically, that's what we're doing here. So notice here we have this one solution, 2, 3, which we already found algebraically. Okay. So that's the substitution method. So sometimes it's easier to use substitution because like we found variables here where it was easy to solve for x. But if we didn't have that, like if it was 2x plus 3y, then we would have something different. And using substitution would not be the easiest way to go. Okay, so elimination is most of the time really the way that you need to solve these equations. So let's figure out how we do that. So first, we're going to choose a variable to eliminate. That's why it's called elimination. And we do that by looking at both equations and seeing what's easy. And I'll kind of walk you through that. Then we're going to multiply one or both equations by an appropriate non-zero constant so that the sum of the coefficients of one of the variables is 0. Again, I'll explain that as we go. Then we're going to add the equations together. And when we do, we're going to get one variable because we're going to have eliminated the other variable. Now, once we only have one variable, we're going to solve the equation with one variable. And then we can substitute the value back into the equations and we can find the value of the other variable. Like we did with substitution, we actually did the same thing with substitution. So for example, I have these two systems and notice neither one has either a 1x or a 1y so this is going to be more difficult to solve using substitution. So we're going to use elimination. How do we decide what to eliminate? Well, if we want to eliminate the x's, then we would have to deal with the -2 and the 3. If we wanted to eliminate the y's, then we would have to deal with the 5 and the 2. So I think what I might do is do it both ways so you can see what I mean. I usually pick the smaller values just to make it easier. So let's just rewrite this. So we have -2x plus 5y equals 29. And we have 3x plus 2y equals 4. Okay? And I'm going to eliminate x. That's the way I'm going to do it first. I'll do it both ways for you. So here I'm going to choose to eliminate x. And to eliminate x, I have a -2 and a 3, and I really want to find the least common multiple, which would be the same as trying to find the least common denominator if it was a denominator. But we're going to say the least common multiple. Well, it's going to be 6, right? So if I multiply everything here by 3 and everything here by 2, because that would be 6. And notice one's negative and one's positive, which I really like because when I add them, that's going to be 0, right? So what's going to happen here is I get -6x plus 15y. I'm just multiplying everything by 3, including the 29. So that would be 27, so 87. Yeah, I don't think I made a mistake. And here we have 6x plus 4y equals 8, right? Because I'm multiplying each one of these by 2. And now when I add these two equations together, notice I've eliminated the x. And what I get is 19y is equal to 95. I divide both sides by 19. And I get y equals 95 over 19. And then I just want to see, is this an actual value? So 95 divided by 19 is equal to 5. So I get y equals 5. Okay, well, great. Now that I know what y equals, so we're starting our ordered pair. We know y equals 5. Now, honestly, I can use either one of the equations to find x. So again, I think I'll pick the smaller one because it just makes things easier. So I'm going to say 3x plus 2, and we already know y is 5, times 5 equals 4. 3x plus 10 equals 4. I subtract 10 from both sides. I get 3x, the 10's cancel, equal -6. Divide both sides by 3, and I get x equals -2. So now I have my ordered pair. My ordered pair is -2, 5. If you plug that in to both equations, it will work, which means that I have one of those graphs that if I were to graph it, it would look well, it wouldn't look like that because it has to intersect at -2, 5. So let's see. So if here's -2 and here's 5, that means both graphs are going through that point. I'm not going to figure out exactly what it looks like, but one of them could look like this and the other one could look like that, right? Because we have one solution. So let's do the exact same thing. Let me copy this. Let's do the exact same thing, but now I'm going to eliminate y first, okay? So again, I start with -2x plus 5y is equal to 29. 3x plus 2y is equal to 4. Now, what do I multiply by? Well, the least common multiple between 2 and 5 is 10. Okay, so I'm going to multiply this by 2 and this by, now notice if I multiply it by positive value, when I add those two equations, I'm not going to eliminate anything. So I'm going to multiply this by -5. So what do I get? I get -4x plus 10y equals 58. And I get -15x minus 10y is equal to -20. So don't forget you're multiplying every term, including the answer, by -5. Then when I add these together, again, now the y's cancel. So I'm eliminating y. And I get -19x equals, and then 58 minus 20 is 38. I divide both sides by -19. And I get x equals -2, which is exactly what I got before. And now I have to find my y, so I can pick either equation. I don't remember, I think I picked the bottom one because it was easier. We'll pick the top one this time. So I have, let's put in this little box here. So I have x equals -2. So I have -2 times -2 plus 5y is equal to 29. This becomes 4 plus 5y equals 29. I subtract 4 from both sides. This cancels, and I get 5y equals 25. Divide both sides by 5, and I get y equals 5. So again, I get the same ordered pair -2, 5. I just, in one way, I eliminated one variable first. First, I eliminated x, and now I have eliminated y. Is that what I did, or did I think I said that backwards? No, that's right. First, I eliminated x. Here, I eliminated x. And here, I eliminated y. Doesn't matter, same answer. So let's do it again. Now, this one, we could do either way, right? I could either solve this using substitution, because I can easily say, if I add 2y to both sides, I can say x equals 11 plus 2y, or I can use elimination. Unless something's super easy, I would practice the elimination if I were you, because most of the time elimination works. I wouldn't say better, but it always works where substitution doesn't always work as easily. So let's begin. X minus 2y equals 11. and minus 2x plus 4y equals 8. Okay, so it just depends on which variable you want to eliminate. I'm going to eliminate x first. I like that because, well, I guess it's pretty much the same, but anything that has a 1 as a coefficient is always going to be easier to eliminate. So what am I going to do? I'm going to multiply everything here by 2. So I get 2x minus 2y equals 22. And here I get minus 2x. Sorry, I didn't multiply, I didn't distribute. So minus 4y equals 22. Minus 2x plus 4y equals 8. Now when I add them together, notice this cancels and this cancels, and I end up with 0 equals 30. Well, 0 never equals 30, right? So I can say for sure that this has no solution. If I were to solve it, I'd find out that the slopes are the same. If I were to solve these for y, I would find out that they both have the same slope. They're parallel, they're inconsistent. Because there's no solution. So how do we write the answer to this? That's another, well, I guess, I don't know. I don't think we have to do what I was thinking. So if we were to do, if we were to actually write a solution, which I don't believe you have to, but let's just do it in case. So I could say that my first solution, so my solution is, let's say here, I change this to x equals 11 plus 2y, or 2y plus 11, because I added 2y to both sides. Well, then what I could say is, well, I don't know what y is, but once I do know what y is, x is going to be 2y plus 11. So if I pick y equals 1, I know x is equal to 13, and so on. So there's no solution because I don't know exactly what those values are, but I can write an answer. I don't know or believe that you will have to do that, so I'm not sure. Okay, so we saw the same thing. We added the two equations. We got 0 equals 30, and we can see that both of the variables were eliminated. So we have a contradiction. 0 does not equal 30. This means there's no solution, and this is an example of an inconsistent system. So notice, if we graph these, there are two lines. They have the same slope, but they never intersect because they're parallel to each other. All right, so let's do another system and see what happens. So I have, again, I have negative 3x plus 6y equals 9, and I have x minus 2y equals minus 3. Now, there's actually two things I could do here, okay? So first, I'm going to do it using elimination the way I already showed you. And I would say here that the best thing for me to do probably is multiply this by 3. Then if I add them together, well, let's actually rewrite this over here. Now notice this cancels. This is 0, this is 0, and this is 0. So what I get is 0 equals 0. So what does that mean? It means it's always true. This has infinitely many solutions. Infinitely, sorry, spelling wrong. infinitely many solutions. Oh, actually, you know what? To the last problem, there's no solution, so I can't write a solution. So my bad about that. There's no solution. We can't write a solution. This one has infinitely many solutions. So we really can write the solution, and I'm going to write it the way I showed you before. So again, and also I wanted you to notice, well, first let's write the solution. So our solution is, and I'm going to again use this, and I'm just going to say X, okay? So my solution is I have some value of X, and once I know what X is, then I can solve for Y, right? So I would, first thing I would do here is I would actually solve this for Y. So I'm going to subtract, here, let's do it up here. X minus 2y equals -3. And I'm going to solve this for Y in terms of X. So I'm going to subtract X from both sides. I'll make it easier for you guys. I will add Y to both sides. So I get X equals 2y minus 3. Now I'm going to add 3 to both sides. And I get X plus 3 equals 2y. These cancel. And now I'm going to divide everything by 2. So I'll divide this by 2, this by 2, this by 2. And we get X over 2. Here, we get X over 2 equals, plus 3 over 2 is equal to Y. So now I can literally put that here. I have X over 2 plus 3/2 is my solution for Y. Another way I can write this is X comma 1/2 X plus 3/2. Whichever way you want. I don't think it makes a difference. So I wanted to show you how to do this, but then as one more thing I wanted to show you. So here I can look at this, and let's go to this page. I wanted to show you that sometimes the easiest thing to do before you start is to see if there's anything that I can factor out of every single term. And I noticed that if I have -3x plus 6y equals 9, I can factor a 3, right? If I factor a 3 out of the first term, I get -x. If I factor a 3 out of the second term, I get plus 2y equals, if I factor a 3, I get 9. I'm sorry, I get 3. Notice that's almost exactly the same as that, except it's negative. So if I were to factor out a -3, I would get X minus 2y equals -3, where this inside here is exactly the same as this. So we started with the top and we ended with everything being divisible by 3. So I can say here X minus 2y equals -3, which is exactly the same as where I started. So we just showed that they're exactly the same line, and how it would be graphed is like this. They're both the same line. So I only have one line, and that's why there's infinitely many solutions, because every point on the line is an ordered pair because both of them are the same. And they intersect at every point. Okay? So now what we want to do is we want to start doing some examples. So Billy has $16.50 in his piggy bank. And in his piggy bank, he has nickels, dimes, and quarters. Okay. So hold on one sec. Okay, so we know that if we multiply nickels, if we add the nickels, dimes, and quarters together, we get $16.50. Billy notices that he has 20 fewer quarters than dimes. So he has more dimes than quarters, right? So let's use this. Let's use this sentence, 20 fewer quarters than dimes, to say that dimes is equal to, so I have 20 fewer quarters than dimes, so I have more dimes, right? So I can say Q, quarters, minus 20. Okay, right? So if I have 22 quarters, I have 2 dimes. Is that right? Let's see, 20 fewer quarters than dimes. I have this backwards. So this is a really good example of when you get things, when you plug in numbers and you get things backwards, check things. So really what I have is that quarters equals dimes minus 20, right? So I have 20 fewer quarters than dimes. So let's see, if I have 22 dimes, I have 2 quarters. Now that makes sense because I have less quarters than dimes. First time I had them backwards. So you should always just plug in a number and make sure that it's right. Okay, so we got that one. If the number of nickels is equal to the number of quarters plus dimes combined. So that means that nickels is equal to dimes plus quarters, right? So let's read it again. If the number of nickels is equal to the number of quarters and the number of dimes combined, so that makes sense. How many of each coin does Billy have? So we have these 2 equations that I don't believe were that difficult to get to. But now our last equation is going to be a little bit more difficult. So let me see if I can explain this so you understand. If you have a nickel and 2 dimes, you have 5 cents plus 2 times 10 cents, right? Or 25 cents. So when I want to know how much money I have, I multiply the number of that item, like nickels, times 5 cents, right? And that tells me how much money I have. If I have 5 nickels, I have 5 cents times 5 or 25 cents, right? So that's how we're going to figure out, using this amount here, we're going to figure out how many of each coin do we have. So first we have to write that equation. So I know that 5 cents is written like this, right? So the number of nickels times 5 cents plus the number of dimes times 10 cents plus the number of quarters times 25 cents has got to be equal to $16.50. Now, I believe on the first video, I think this is the easiest way to go, so you don't have to work with decimals, is multiply everything by 100. If you multiply everything here by 100, then what happens is you get rid of the decimals because there's 2 decimal places. So 0.05 times 100 is 5N plus 10 cents times 100 is 10D plus 0.25 times 100 is 25Q is equal to 1,650. Now, at least now I don't have any decimals, okay? So let's see what I can do here. I need to eliminate something. So I know that the quarters is equal dimes minus 20. So let's start there. So I have plus 10 dimes plus, now for the quarters, I'm going to say 25 times, and I'm using Q equals D minus 20. And I say that's equal to 1650. Okay, so hopefully that makes sense. Now, if we can somehow get nickels into just dimes, then we're in pretty good shape, right? So I know nickels equals dimes plus quarters, so let's start with that. I have 5 times D plus Q plus 10D plus, and I'm just going to multiply this out or distribute, 25D minus 500 equals 1650. Okay, so now I have 5D plus 5Q plus 10D plus 25D minus 500 is equal to 1650. Okay, hold on. Let me put in another slide here. And what I'm going to do is copy, let's see, what do I want to copy? Let me do something here. So I want to, hold on. There we go, send it back. So what I'm going to do now is I'm going to copy this right here. I want this last line here, or I'll take the last two. So we're going to copy and paste. And I also want this. So I want to copy this and paste this here. Okay, so now I have really what I need. Okay, so let's see first if we can, I think let's just simplify this a little because we have things we can combine. We might as well combine them to begin with. For example, I have 5D plus 10D, which is 15D, plus 25D, which gives me 40D. Well, that simplified things quite a bit, right? Plus 5Q minus 500 is equal to 1650. And then let's add 500 to both sides. And we're going to make things look even better, right? So I have 40D plus 5Q is equal to 2150. We're getting close. But again, I need Q in terms of D. But don't forget, I have this equation. So I can now say, here, I'll change back to red. I can now say 40D plus 5 times Q. Well, Q equals D minus 20 is equal to 2150. So let's continue. 40D plus 5D minus 100 is equal to 2150. 45D minus 100 is equal to 2150. 45D, and I'm going to add 100 to both sides. So I add 100 to both sides. These cancel, I get 45D is equal to 2250. So now I divide both sides by 45. and I get D is equal to 2250 divided by 45. Just give me 1 second. Let me actually get my calculator out for this, so I don't make any mistakes. So 2250 divided by 45 equals 50. So that means I know now I have 50 dimes. Once I know how many dimes I have, so here, I'll write it out here. So I have 50 dimes. Now I can go to my first equation because I know I have 20 less quarters than dimes. So the number of quarters I have is 30, right? And then I just have to know how many nickels I have. Well, nickels I have is 50 Q plus D, which is 50 plus 30, or 80. So I've now found out how many of each thing I have, right? I have 50 dimes, 30 quarters, and 80 nickels. And then what you could do is you can actually calculate this. Should we do it? Yeah, let's do it. Just to make sure that it's correct. So let's put a new slide in here. And so we said we have 50 dimes, 30 quarters, and 80 nickels. D equals 50, Q equals 30, and N equals 80. So let's do it. So we know we have 80 nickels. So we're going to multiply that by 0.05, because 5 cents. So 80 times 0.05 is going to be, again, I need my calculator. I think I know, but I don't want to get it wrong. So 80 times 0.05 equals 4. So 80 times 0.05, which is the amount of the dollar amount of nickels I have, is $4. Okay. Then I have, this is in nickels. Let's do dimes. So I have 50 dimes. They're each worth 10 cents. So that means I have $5 in dimes, right? And quarters, I have 30 quarters times 0.25, which is equal to $7.50. So let's add all that up. $7.50 plus $5 plus $4 is equal to $16.50, which is exactly what they said it would be equal to. So I know that's a little more complicated, but that is how you solve that kind of a problem. And if you're confused, don't forget, you can always come to see me in office hours, or you can rewatch the video and see if it makes sense a second time through, but that's how you do that. So again, I know we've gone over this a few times. I'm going to go over it again. 5-step strategy for problem solving using system of equations, which is really the same as what we saw before. Before it was 4 steps. So we want to read the problem until we understand. And if possible, create diagrams, charts, or tables. So I would say basically that, or make sure you can draw, if you can draw a picture, okay? And then choose the variables that describe each unknown quantity. So I did D, N, and Q because that way it was easy for me to keep track of dimes, nickels, and quarters. If you use X, Y, and Z, you're going to have to write somewhere what each of those things stands for, because in the end, you won't know. Okay. And then write a system of equation using the given information, which we did. This is our systems of equations. Actually, we have 3 of them. This is also included in the system of equations. Okay. So there's 3 systems because we have 3 unknowns. Remember I said, if you, as many unknowns as you have to have that many equations. Okay. And then solve the systems of equations using methods of elimination or substitution, whichever seems to work best. And then make sure you answered you've answered the questions and check all answers to ensure they make sense. Well, we did check our answers, and the question says, how many of each coin does Billy have? We answered that question. Billy had 50 dimes, 30 quarters, and 80 nickels. And we checked our answer to make sure that it made sense. And it does. So that's basically how you do these systems of equations. Again, if you have any problems or any questions, please feel free to reach out. I'm happy to help.